All right, first up, let's start off on number 2 here. So for this one, we want to find a function that models the area in terms of W. So I'm gonna set this up as my main equation here is area. Now I know area usually equals length times width, but I want this in terms of W, which means W should be my only variable. So I'm gonna build a substitution equation over here. That's gonna be based on the fact that it's 10 inches longer than it is wide. And so what I'm gonna say there is that L equals W plus 10. Because the length is more than the width, I actually need to add 10 to the width to get to the length. So some of you may have thought that you add 10 over here, but actually we add 10 to the width. Because it's smaller, we need to add 10 to equal it to the width. You can kind of imagine if the width was 5, the length would be 15 according to my equation, which actually makes sense there. So I can use this to substitute into my other equation here. Swap it out for L, which will kind of accomplish my goal here. And so I get area equals W squared plus 10W. All right, next up, number 6. So this one, the rectangle has an area of 16 meters squared. Find a function that models P. So my main equation is gonna be perimeter. So for a rectangle, that's 2L plus 2W. And so then my substitution equation, the one I know more about, is actually going to be area. So that'll be 16 equals length times width. And it says find a function that models perimeter in terms of the length of one of its sides. So it doesn't really specify. So I can actually kind of isolate either one of these variables. I'll go ahead and isolate W, I guess. So it doesn't really matter. So 16 over L equals W. So I can swap that out here for W. So I get P equals 2L plus 2 times 16 over L. So then we could simplify that and say 2L plus 32 over L. If we want to do a common denominator here, you could also answer it as, let's see, we'd have to multiply this by L, so that would be 2L squared over, 2L squared plus 32 all over L. Now they said to call this one side X, and so I'm just going to kind of translate both of these. So I would say that you can say 2X plus 32 over X, or you could say 2x squared plus 32 all over x. So that's just switching the variable to use what they wanted. All right, next up here we got number 23. And you know what? You can actually, you can kind of skip part A if you like. You can just focus on B and C there. You can do A if you want. So that's that. So, okay, I'm going to move on to the next one. All right, so number 24, kind of like number 23 here, we have 750 feet of fencing, and we're trying to maximize the area. So I know my main equation is going to be an area formula, so area equals, and what I'm going to do here is I'm going to label this side X and that side Y, so area would just be X times Y. Now my perimeter here is going to be my, my substitution equation, or actually it's more like a fence. So I know that I have 750 feet of fence. And I just need to count out how much fence I need here. So I see that although this is X, I actually have another X right there. X, X, and X makes 5X. And then I have another Y over here, so I'll need 2Y of fence. So you can see by the picture that that's what I need for the fence. So I need to isolate one of those variables. So I'm going to go ahead and isolate Y here. You could isolate X if you wanted to. It really doesn't matter. So I get 750 minus 5x equals 2y, and then we'll divide everything by 2. I think that's 375. Let me just make sure. Yep. So 375 minus 5 over 2x equals y. So now I can swap that out right there. So I get area equals, let's see. That would be x times 375 minus 5 over 2x. And then I would go ahead and distribute that and rearrange it into standard form. So I got negative 5 over 2x squared plus 375x. All right, so that's really my answer for part A. Just find the function. So now part B, maximize it. So I'm going to find the vertex then, since this is a negative parabola. So I got negative b over 2a. So that's negative 375 over 2 times negative 5 over 2. Now I see that these actually cancel out, so it's just negative 375 divided by negative 5, which is 75. So I know that this length should be 75. It asks for the possible area, the largest total area of the 4 pens. So I'm just going to actually answer this by plugging it into the area. I could find y and then just multiply x and y together, but since I have this area formula, I'm just going to plug 75 into it, type it in my calculator, and get the answer here. And so this one comes out to 14062.5, and that would be square feet as the units. So that's the total area that I can enclose. With that amount of fence, that would give me the largest possible area. All right, next up, we got 27 and 28. So these ones we're trying to either maximize revenue or profit. So 27 is very similar to the one we did in class. 28 actually has to do with profit, which is a little more complicated, but it's still not going to be too bad. So the big thing with profit is that profit is your revenue minus your cost. And so I can already see that right now our revenue per unit is $10, and then minus the cost of $6 is going to give me a profit of $4. So my profit right now is $4 per feeder that I sell. But that is going to change as we go along here. So I'm going to kind of make my main profit equation right here. So profit, I'm going to say, is equal to x minus 6, which I'm going to let x equal the sales price. And so right now that's $10, but that can change here. But whatever it is, I'm going to subtract 6 because that cost is going to stay consistent. So you can kind of see this is what I did right here. Right now, though, the sales price is 10, but that can change. And then I'm going to multiply that by n, and I'm going to let n equal number of sales. Once again, we know what that is right now. It's 20 per week, but that is going to change as we go along here. Okay, so now what I'm going to do is I'm going to set up my substitution equation here. So my substitution is how many am I going to sell. So right now I'm selling 20 per week, so I'm going to start off there. But then I find out that that if I increase it by $1, increase the price by $1, I'm going to lose 2 sales per week. So what I'm going to say there is I'm going to subtract 1. I'm going to lose 2 sales for every dollar a week, for every dollar that I increase the price. And so in here I'm going to put x minus 10. And so what we can see here is that if I kind of in my mind plug in 11 right here, I raise the price by $1, which then turns this parentheses into 1, which makes me lose 2 customers. It also works backwards. So if I plug in a 9 here, that means I'm lowering the price by $1. This turns into -1, which gives me 2 more customers. You can kind of also do this the other way. You could do n equals 20, and then you could add 2 customers, and then you'd switch this around. So that means if I lower the price, then I'm going to gain 2 customers. So if I kind of make that a 9, then I'm lowering the price by $1, which increases 2 customers. So either one of those will work. I just need to simplify one of them. I'll go ahead and simplify this one since that's what I started with. You'll notice that if you simplify either one of them, they're going to end up being the same thing, a positive 20 and a negative 2x. So that's going to be negative 2x plus 40. So I'm going to plug that in here to my profit equation. So I have x minus 6 times negative 2x plus 40. I'm going to go ahead and simplify this, which is going to require a FOIL. So I got negative 2x squared, and then positive 40x and positive 12x gives me positive 52x, and then minus 240. And so that's my answer for part A. Part B asks what price should they charge to maximize the profits. So I'm going to do x equals negative b over 2a. So that comes out to 13. And so that means they should sell these things for $13 each to maximize their profit. If they sell them for more, they're not going to get enough customers to make that up. If they sell them for less, they're not going to make enough money, even though they have more customers. And then we'll find out what is that max profit by plugging this in. And I would just use a calculator for that. And it turns out that their max profit is $98. So it doesn't seem like they're making a lot of money that in a week. And so if that answer doesn't make sense to you, what I would check against is like how much profit were they making originally? So originally they were making $4 per feeder, and they were selling 20 feeders, so they're making $80 per week. So I just increased their revenue to $98 per week. So I did help them, not a lot, but that is actually the most money they can make. So maybe they should think about building something else.